part of that was, you mentioned the collision of the black holes. So what happens to the black holes when they collide with each other?
Well, so that they have to be very close. And so they started out probably, these are so-called stellar-sized black holes that are the product of massive stars, much larger than the sun, ending their life and exploding catastrophically in this thing that we call a supernova. And one of the end states, one of the end possibilities that's left over is a black hole that's 5 to, 30 times the mass, 50 times the mass of our sun. And so stars can form in multiple star systems. Maybe you have two stars that have formed together and they're gravitationally bound. They're about the same mass because mass dictates the lifetime of a star. And, they both explode as supernovae, and now you have two black holes left over. They're orbiting each other. Over time, they're losing energy for a variety of reasons, and they start to spiral in. Their orbit around each other gets smaller and smaller. And as they spiral in, there may be some subset of those objects that get so close that they collide. And what happens is they merge and form a larger black hole than the two, than the two individual ones. So, you might have 220 solar mass black holes. They in-spiral. When they merge, they release a little bit of gravitational energy, so they may lose a couple of solar masses, and then they end up with like a 38 solar mass black hole. And it's an individual black hole. Well, that process, as they're spiraling around each other, remember, they're a very dense, they are deforming space-time significantly. And as they orbit around, they're releasing energy in the form of gravitational waves that travel through the fabric of space, and then LIGO detects them. And so typically what we see is the gravitational waves as they're in-spiraling, and then when they merge, they kind of, as a single object, they kind of wobble. The merged black hole kind of wobbles, and it sends out ripples, and so we see those ripples, and then the gravitational waves die off, or at least we're not able to detect them once that kind of settles down. So that's what LIGO is detecting at the moment. That sort of process, either in gravitation, in black holes or in spiraling neutron stars, does the same thing.
Very cool.